Hello, everybody, and welcome to another edition of Let's Talk ETC. I have a special guest with me today, Paul Lintilhac from ConsenSys, and he works in the field of artificial intelligence, machine learning, and blockchain technology. He's involved with some projects that combine all of those technologies, and I thought that would be an interesting topic because a lot of people, first of all, in the audience don't know about machine learning, and they might not even realize that you can leverage both of those fields, machine learning and blockchain technology, to do some innovative things. So I thought it would be a great show to talk with Paul. So welcome, Paul, to the show.
Thank you so much, Chris. Thank you for having me here. I really appreciate it. And, I love talking about machine learning and trying to spread the word on that, and also blockchain. So yeah, thanks a lot for having me. And
so why don't we start by telling the audience a little bit about yourself, your background, education, what you're doing at ConsenSys, so that they have kind of an idea who you are. So why don't we start there?
Yeah, absolutely. So my background in college was math and physics. I went to Dartmouth and did a double major in math and physics. And towards my senior year, I got really interested in algorithmic trading. And this was when I was still sort of just a math and physics guy. I didn't really program too much, but I got interested in programming through quantitative finance because it just seemed like a really interesting application. It's almost like a magical thing to be able to write some code and do some math and then unleash this algorithm on the market and have it actually make money. Is a really interesting prospect, I think. So I got really interested in that. And then after my undergraduate program, I sort of taught myself how to program and taught myself Java. And then I applied to the Quran Institute's master, that's the NYU Mathematical Institute. And they have a great quantitative finance program. So I started attending that and taking some classes in the relevant mathematics and the relevant finance, a little bit of programming. And around that time, I also got interested in blockchain. At that point, actually, people weren't really talking about the blockchain so much as just Bitcoin. And they hadn't really become these very distinct concepts yet. But basically, I had a friend who was a really talented trader. His name's John West. He also was working at ConsenSys with Omega One, which is a trading platform. And anyways, he was doing arbitrage in the Bitcoin markets. And so I knew about arbitrage. I had been learning about this in my master's program. And I recognized it as a big opportunity because one of the reasons that my trading algorithm in college didn't work was that I was just trying to do it in the S&P 500 futures market, which is extremely efficient, and you're totally outmatched by these huge banks with their $1 million connections to the New York Stock Exchange and fast computers and teams of PhDs. So I was like, okay, this seems like a more bite-sized problem that maybe I can tackle. There are these big spreads between different Bitcoin exchanges of 5-10%. So I thought, okay, maybe I'll try to take my newfound programming skills and build a trading system from scratch. And the great thing about that also was that in this world of blockchain, there are a lot of these APIs are open. So all these exchanges have open APIs that you can connect to. Rather than having to purchase some kind of commercial trading software, you can really just plug into them and build your own system. So that's what I started doing. And then as I continued in school, I continued trading sort of on the side. We eventually got this system running, and it was running successfully for a while. I developed my own sort of algorithm for the arbitrage. And then, unfortunately, what happened was around half of the funds that we had invested were stolen in the Mt. Gox hack.
Oh no way! Oh, so you were one of the victims of that. Oh gosh! Wow.
Yes.
Okay.
We were, unfortunately, and we actually at the last minute, when the price crashed from around $650 on that exchange to around $150. So I had sold when it was high, and then it dropped down to 150, and I bought back. So I made a bunch more Bitcoins there. but of course, they weren't realized because still
Yeah.
waiting on that class action lawsuit to be resolved.
Okay, so we're
Hmm.
definitely kindred spirits because I've always been interested in kind of uh, the kind of more mathematical software applications like quantitative finance. Although I never had a job in it. I tried to apply for it, those type of jobs at one point. Even was
Hmm.
thinking of going to New York, but then so I can see how you would be attracted to machine learning because that's another kind of mathematical software field, and so your skills in math could and your interest in software could be married by. I can totally see you going into that. And
Hmm.
so and also it was interesting to me that you said that you realized that there was a lot of competition from the big boys in regular arbitrage with stocks, but then you didn't give up. You said, I can go to this newer field that doesn't have as much competition, and and so that was kind of impressive. But you didn't mention how successful. Or first of all, were you successful? But barring the Mount Gox issues,
Hmm.
did your arbitrage system work better in Bitcoin land?
Yes, yes, it did. So actually, the system that I made in college wasn't even arbitrage. I was trying to do sort of technical analysis type algorithms, and now my opinion about that has changed. I basically think most of it is juju and sort of pseudoscience.
Uh-huh.
A lot of the technical analysis stuff. But one thing that's always true is that if there's an arbitrage opportunity, then you can, if you execute correctly, you can make money off of it. And it was successful. There we made around a 40% profit, I believe, in around 5 months. To be fair, some of that was actually manual trading.
Mm-hmm.
When the system was still kind of stabilizing, if there was a really big trade, we would turn the system off and trade it manually just because we wanted to be extra sure. But the system was running successfully and making a profit and contributing to that for a while.
Mm-hmm.
So, in terms of my kind of metaphysical satisfaction, I felt like the proof of concept was there. And I was pretty happy that worked out,
Mm-hmm.
even though it was a pretty small amount of money. It was more about the proof of concept. But then I still had a lot of questions that were more related to the theoretical aspects and the mathematical parts.
Right.
I had this trading algorithm that was basically based on thresholds and sort of a set of rules. But the question for me then became, what is the general formula here for arbitrage? And can this algorithm be justified by any kind of mathematical framework?
Mm-hmm.
Or if there's some more like a continuous trading strategy that would kind of mirror this. So that was what I decided to do my master's thesis on
Yeah.
in my second year. And what that was all about was, yeah, using stochastic optimal control theory to solve for the optimal arbitrage strategy.
Right.
Um, and it was really interesting to me because when I looked at the research, there was a lot out there about when you have two assets that
Mm-hmm.
are kind of mean reverting or they're a little bit out of whack, how you can optimally trade them. That problem had been solved, but it was really interesting to me how the problem with multiple assets had not really been solved in a general case.
Mm-hmm.
And another interesting detail there is that when you have multiple assets, you can have multiple different mean reverting relationships, kind of independent or orthogonal mean reverting relationships. So there's two levels of generality that weren't really there. One of them was when you have an arbitrary number of assets, and then the other one is when you have kind of arbitrary mean reverting relationships. So that was what I did is I solved the problem and generalized that math to the case of arbitrary assets and arbitrary mean reverting relationships. And then I actually applied it in the Bitcoin market. So I kind of tied it
Right.
back into my practical experience and did some tests for that, and then eventually published it in the Journal of Quantitative Finance in 2016. Um, and so that was kind of a long epic of my interest in algorithmic trading, starting in college and then going through the practical side and going to the theoretical side. It's almost a little bit opposite from what a lot of people think. Usually you start with the theoretical and then you go to the applied, but
Right, right.
in this case, it went in the other direction.
And why did you, or how, what made you decide to focus now on machine learning rather than continue to try to corner the market, right, and make your mark in cryptocurrency
Mhm.
algorithmic trading? What made this the switch for you?
Yeah, so I mean, a lot of the basic math behind algorithmic trading, optimization, stochastic control, a lot of that mathematics is pretty similar. A lot
Mhm.
of it could very broadly be put under optimization.
Okay.
Um, but yeah, I also worked as a data scientist after my master's program for a little while before going back to school and going back to ConsenSys. So
Okay.
I got some experience as more of a general data scientist building risk models for a company called OnDeck, and
Okay.
sort of yeah, got my chops there. And I built an inventory management system for a fashion company. So I had some more practical experience as a data scientist. And then I was like, okay, I guess I'm a data scientist now. Um, so yeah. And then what really got me interested in the more advanced machine learning stuff was my studies at when I went back to Quran for the PhD, um, and also at the engineering school at Tandon School of Engineering at NYU, and I started learning about online learning and graph algorithms and more of the theory there, and that's when I got interested in more general machine learning.
I see.
So I'm still at the PhD part time at NYU for math,
Gotcha.
and mhm.
So you're obviously a smart person with lots of varied talents and interests. So I have to admit, I didn't understand all the things you said, the terms you use for algorithmic trading, but that's okay. But let's switch gears now a little bit. Let's try to give the audience a very gentle introduction to what in the world machine learning is. And remember that we're not experts, so try to keep it as low level as you can. So, you want to try that?
Sure, yeah, absolutely. Yeah, so machine learning is, I think sometimes it sounds a little bit scary to people because it has the word machine in it.
Mm-hmm.
And of course, it's has its roots in computer science, but in a lot of ways, it's also just math. And some professors that I've had have just called it learning theory, because really that's what it is. When it comes down to the theory, is it has nothing to do with machines. It's just it's algorithms for learning concepts. So just to explain that in a really high level, it's taking data and trying to extract knowledge from it and trying to extract meaning from it. And so that could mean trying to take existing data and find patterns in it that sort of explain it in a simpler way.
Mm-hmm.
That would be like unsupervised learning.
Right.
Um, and an example of that would be, for example, anomaly detection. If you have a whole set of data that describes 1,000 different people, then you can use sorry, I was getting a call on the other line. It's a little distracting. Um, but so unsupervised learning is basically extracting patterns from data, but it's not predictive in nature.
Mm-hmm.
You're just sort of gaining knowledge by simplifying a data set down to its core components.
Right. So
Um,
that's so for us people that aren't as expert as you. So yeah, that was kind of my understanding. So unsupervised learning. So there's two kind of bins that machine learning falls into: supervised and unsupervised. And I'm sure you'll in a minute you'll talk more about supervised, but unsupervised to me it was exploratory, right? Like you said, looking for patterns that you don't even know if they're there or not, right? So it's just
yes.
kind of like a pre-processing step before you do supervised learning in a lot of cases. Would that
In a
be?
lot of cases, yes. I think there, yeah. So just to give, I know this is a little bit technical, but just to have some words to throw out there, examples of unsupervised learning, there's novelty detection, things like clustering, which is a very popular thing in machine learning. A lot of times when people are talking about data mining, a lot of times it seems they're referring to clustering, because you're basically trying to extract these nuggets of knowledge from a data set, and that represent the whole. So clustering, things like principal components analysis, these
Yeah,
are all.
that's a great example, and I think that's probably the best one for teaching purposes, and that might be the only one that a lot of people understand. So, talking about finding unknown patterns, the people might wonder, well, how in the world do you write a program to do that, right? But clustering is, you can explain it as just, well, you graph your data, so it's a bunch of dots, and then you just see if a bunch of islands appear, right? And so that's what you mean. And so if you explain it that way, it doesn't quite sound so exotic and mysterious, right? You're looking for islands of dots, and that's what we call pattern analysis, which sounds so much more threatening. As far as other example, I don't know if there's other examples that are as easy to understand as that, but I really like that one, clustering.
Yeah, absolutely. I think you're right. That's probably the easiest one to understand, and it does get complicated with clustering. One cool thing about clustering is that it gives you this sense of some kind of a space where there's like a distance that's defined between your different data points. So it's really easy to understand because there's that nice analogy of, if you can kind of represent this space in 2D or 3D, then you can show a bunch of points and you can show how there are these little clusters, and then you can paint that cluster yellow and paint that cluster green, and then you have sort of broken down your data set. You've reduced the dimensionality of it. So yep, that would be unsupervised learning.
All right, so then why don't you introduce, this is the one that I think the audience will be able to understand a little better, but why don't you now touch upon supervised learning?
Yeah, so supervised learning is when you have basically you have a bunch of data, just like in unsupervised learning. Maybe it's in a big table where each of the rows is a different observation, and then each of the columns is like a different kind of metric that you're using. So that by itself is sufficient to do unsupervised learning. In order to do supervised learning, you have this extra thing, which is the response or the label. You could think of it as another column that you're kind of attaching to that initial data set. What it represents is the thing that you're trying to predict, or the thing that you're trying to classify. So essentially, it might be that you have a bunch of data about 10,000 different people. Maybe there's 10 different dimensions there that you can use, but rather than just trying to describe that data set, you're trying to use it to predict whether or not they voted for Donald Trump, for example, or anything, any kind of variable that you're trying to predict. So the idea is that you have a bunch of these known labels, and you can use them to train your algorithm, to train your supervised machine learning algorithm, so that basically the data that you have can be, you can make a prediction that's as close as possible to your actual labels, so that it's sort of calibrated to predict that label. And there are many, many different ways that you can do this, but the idea is that now in the future, if you get totally new people that have these different features, but you don't actually have the label. So I have all these 10 different dimensions for this person, but I don't know whether they voted for Donald Trump. Now I can run them into this black box and turn the crank, and it will output a prediction that will hopefully be close to the actual predicted value. And in fact, you can prove that it will be fairly close to that value under certain conditions.
So if we can describe unsupervised learning in general as finding patterns as exploratory, and is it correct to say that with supervised learning, you always have a set of inputs and outputs, and you're asking the computer to find a function or a bridge between those two? Would that be?
Yep, absolutely.
Okay.
Yeah, so you're trying to find a function, but then the problem is that there's no way to find an exact function, because if you have 1,000 different people and 1,000 different outputs, you only maybe have 10 degrees of freedom that that your model is using to try to predict those. So it's inherently approximate. I mean, of course, if you had 10,000 degrees of freedom, then you're going to be 100% correct, and you could predict the labels 100%. But if you get new data, it's probably not going to predict it very well. So the idea is you want to balance having a simple model that has a lot of generality with something that is going to be highly accurate.
Right.
Yeah.
Now, and then before the show, I was trying to think of how to brutally simplify what supervised learning is. And I don't know if this is correct, maybe this is dumb, but I was trying to think why computers could learn on their own and why they can impress us so well with, like, for example, learning chess and Go. And is it correct to say that the reason they're able to do this so-called magic is just because of it's extreme memorization? Like, for example, imagine we said we're going to make a computer that could be great at math. Then you could imagine, we would never do this, but an extreme way to become a great mathematician would be to memorize the answers to every math problem on the internet, on the web. And then and when somebody asks you a question, either it's going to be one that's previously been asked somewhere in history, or you could say, well, I'm going to try to figure out what's the closest one that I've memorized. You could appear to be good at math. So the point I'm trying to make is that's basically what computers are doing when they do supervised machine learning. It's extreme memorization that humans couldn't do. Is that right?
Well, I think it relies on a superhuman ability to analyze massive data sets and calibrate to those data sets. But I would say it's not just strictly memorization, because I think what it is it involves a model for how you think those inputs might be related to that output.
Okay.
And this is where the model development process comes in. Is there are many different kinds of models where so what the model specification is you're saying, I think there's generally maybe a linear relationship, or there's generally XYZ type of relationship, but I'm going to leave some degrees of freedom there. And then from that point on, it's just turning the crank and sort of processing the data. But there is a subjective decision involved there, which is, I think that it's this general type of model. So that kind of requires a little bit of understanding. And from that point on, you're reducing that relationship between the inputs and the outputs to just a few numbers, really, maybe 5 or 10 numbers. So you're describing a data set of tens of thousands, millions, billions of data points with only a few numbers plus a general concept of the model.
Okay, so you're trying to find the structure that maps the inputs to the outputs. And the structure can be surprisingly simple, is what you're saying in a lot of cases. Is that correct? 100%?
Absolutely.
Okay.
Yeah. So just to give a really, really simple example, this is what I like to use as kind of the simplest possible useful supervised machine learning algorithm would be a regression. So I think a lot of people who took college or even sort of advanced high school statistics, they had a bunch of data points that they plot on an XY scatter plot, and they kind of make this big cloud. And in Excel, there's a function where you can find the best fit line there. And so that best fit line is the process of creating that best fit line is a machine learning process. And the actual best fit line itself can be described with just two numbers, a slope and an intercept. And yet you can describe thousands of data points approximately with just those two numbers. So it's not that you've memorized every single point that's on that plot. You've taken it and you've tried to reduce it to a model. You say, okay, I think I'm going to assume there's a linear relationship here. And then you turn the crank and it solves for the slope and the intercept. And then there's your model, and it works pretty well. and
Right.
it's just two numbers.
So you found the structure in the points. That's right. So then that you're saying that would be an example of machine learning. And then there's like handwriting recognition. Somehow they see structure in the handwritten numbers or letters, and they do mathematics to do that no human could necessarily describe how they do handwriting recognition. So yeah, it's all.
Mhm.
Oh, you wanted to say something else?
Oh, no, I mean that, yeah, that's absolutely right. As long as you have some definition for what your error is,
Uh-huh.
in the case of that regression, one thing that's important to point out is you're minimizing the squared error. So if you take the vertical distance between your data points and that best fit line, you
Mhm.
square it and you sum up those things up. We're kind of arbitrarily calling that our error.
Okay.
And that makes sense in that case. In the case of handwriting, you would have basically your error is, am I correctly predicting that it was Johnny who wrote this?
Right.
Yes or no? And then you can somehow use that to quantify your error. And as long as you have that metric for how well you're doing, then you can learn and get better at predicting it.
Right. Very good. Now, my sense is that machine learning is growing by leaps and bounds now, just like the blockchain sector is. And I suspect that there's lots of startups that are applying machine learning to all these areas that haven't maybe used it before. And so there's lots of opportunities, like just like applying blockchains to different sectors is a fairly new idea. Is that going on now? Is there a lot of opportunity?
Absolutely. I think it's kind of one of the hottest fields right now that it's growing very quickly. Everyone's talking about AI this and AI that, just like that people are talking about blockchain this and blockchain that.
Mhm.
And I think it has a similar quality with blockchain where it really is a transformative technology. But then I think some people maybe aren't using it correctly, or they're hyping up the wrong things and not focusing on the real end goal.
Mhm.
So in the case of machine learning, I guess what I'm referring to about some people sort of abusing the hype around machine learning is that a lot of startups these days they're doing something, a recommendation system or some kind of a marketplace, and it's just kind of in fashion right now to hire a data scientist or a couple data scientists and quote unquote sprinkle machine learning on everything, and there's this vague understanding that it will make everything better.
Mhm.
And so I think that's happening a lot right now, but that's not really, I would call that sort of applied data science, where you're not necessarily coming up with new algorithms. You're essentially taking a
Right.
known algorithm and applying it in a new context and hopefully adding some value. So that's definitely happening all over the place.
Mhm.
But then I think there's also a lot of fundamental research that's happening in machine learning, and that is also uh, being the focus of research at a lot of these large corporations. Facebook, they're using machine learning
Right.
to filter out terrorist posts that were made by potential terrorists, and they say they have a 90% success rate.
Mhm.
Google obviously is
Right.
working on a lot of machine learning stuff. So I would say those are the people that are really pushing the industry forward, and then their research and work, and also of all the academics around the world, filters down into the tech space. And then these new algorithms get coded up by someone and put into a package, and then basically you just import it and use it.
Right.
Um,
Yeah, no,
so
that's good.
yeah,
So you're saying that the state of the art is increasing. There's lots of smart people in industry and academia pushing the boundaries, but then there's also people applying the existing state of the art technology to different industries. And
yeah,
I think there's excitement, and there's places for everybody to contribute. Just out of curiosity, if somebody in the audience wanted to apply machine learning wisely to their little pet project, can you just quickly say how they would get started, or what, not make a fool of themselves? How
yeah,
they?
that's a good question. I think Well, you could start off by picking a programming language and sort of what kind of libraries you want to use. I would say the two biggest machine learning languages right now are for data scientists are Python and R.
Hmm.
It's probably good to know both of them, but you can do almost anything with either of them.
Hmm.
I personally really like R. But yeah, if you can start learning how to use R, and they have all kinds of built-in data sets, there's all kinds of interesting data sets out there that you can play around with. Um, then
And
you
then what about
can,
the Microsoft Windows? In other words, the popular tool that all the cool kids use is I've heard of TensorFlow from Google. Is that what it
right.
uses for applications?
Yeah, so TensorFlow is becoming really popular, and in general, I think uh, deep learning is becoming very popular. I would say the TensorFlow and deep learning is one of those things where it may be overused by a lot of people who don't necessarily understand the theoretical aspects behind it.
Uh-huh.
And I think deep learning is kind of like a sledgehammer.
Hmm.
So I tend to like the philosophy of you should try to look for nails and then, find the appropriate hammer rather
Uh-huh.
than taking a sledgehammer and going around searching for nails.
Right, right.
Um, but there are definitely situations where these really popular things like TensorFlow and all these other deep learning technologies can be useful. For example, machine vision is a really big one,
Mhm.
and algorithmic trading is definitely one. And I think actually these days sometimes machine learning is taken to be synonymous with deep learning.
Mhm.
Um, but that's not really the case. It's a specific type of machine learning. But
So just to be clear for the in case the audience doesn't know what deep learning is, my understanding is it's a type of neural network technique that's very complex, has lots of levels of neural networks, and the reason it's not necessarily that it's new, but the reason it's taking off now is these huge neural networks are possible now because of increased computing capabilities. Is that correct?
yes, absolutely. And that's actually one of the places where machine learning intersects with blockchain in an interesting way in terms of the technology and the hardware is that one of the main things that you want if you're going to train a deep learning algorithm is massively parallel processing. So GPUs happen to be a really great piece of hardware for that, and it just so happens that those are also what people use for mining, as you
Right.
know.
Mhm.
So it's a lot of times it doesn't take much to take an Ethereum mining rig and transform it into a deep learning system
Uh-huh.
because they both require massive parallelization. So yeah, it's becoming very popular and it's really powerful. Actually, I haven't focused as much on deep learning in my research because in a lot of ways we don't totally understand why deep learning works as well as it does from a theoretical perspective
Mhm.
when you compare it to some of the other popular algorithms, like support vector machines or decision trees, or that the list goes on. There's very concrete. You can, like I said, you can actually make proofs that it works pretty well. Whereas with deep learning, the the mathematics behind that are still sort of not super informative. And for me, I like to have that theoretical backing behind what I'm doing. So
Right.
I think I've actually focused. I haven't focused as much on, excuse me, on deep learning
Mhm.
personally. And I think that would be my recommendation probably for a lot of people is if you want to learn about deep learning in school, you can probably get a great job with it, and it's really useful. But definitely don't ignore some of the more fundamental stuff of learning why a support vector machine works, learning why boosting works, and
Mhm.
really understanding logistic regressions. They're a little bit less sexy,
All
but
right.
when you're working at a job at a bank or at a lending company and you're building risk models, you're not going to be using deep learning. More likely, you're going to be doing a logistic regression on everything, and just kind of, it
Right.
works pretty well, and it's pretty simple. It's very easy to interpret is another big benefit of the simpler algorithms.
Right.
When when you have a logistic regression, if that's determining someone's credit approval, if they want to know why did I get rejected, you can go look at your logistic regression and say, well, based on these coefficients that I have here, this one factor that you had was the reason for the rejection, and you can trace it back to exactly why that person got rejected.
Right.
Whereas with deep learning, there's this layered neural network, and it's not as clear what a given factor in that model actually represents in the real world. So
Right.
in terms of regulation, and in terms of a word people like to use, of parsimoniousness, or having a model that you can actually understand intuitively, the simpler models have a big advantage there, I think.
Right, right. So it sounds like one of the things you're saying is that you recommend people do their due diligence and learn about lots of solutions rather than hoping for one specific end all be all technique that's gonna solve everything. Is that correct?
Yes, absolutely. Yeah,
Now,
I would recommend looking at the whole canon. Yeah.
now the reason I one of the reasons I asked that question I was that I just read a book recently called The Master Algorithm, and the book's vision was to find exactly what I'm saying, a machine language general purpose technique that worked in every case. And so I was groping for something that maybe an entrepreneur that's listening could write some general purpose black box that they could use for their specific product or their specific application without needing to bother with having to select from different choices, things like that. But I guess you're saying that doesn't exist yet, so you still have to do your
Well,
homework.
yeah, there's actually an interesting theorem in theoretical computer science called the no free lunch theorem, or maybe I'm getting the words wrong, like not exactly correct, but essentially what it says is there's no algorithm that is superior for every possible use case. There's always a certain use case where that algorithm is not optimal, and you can actually prove that that's the case. So there's definitely no silver bullet. There are some things that are more general purpose, and I would say deep learning is very promising as something that's extremely general and powerful, but there's definitely nothing that is superior in every scenario for every objective.
Right. Well, not to belabor this point to death, but just thinking of the entrepreneur out there, if I can just ask one last question. So it sounds like the closest thing to the holy grail that we have right now is deep learning. And you said we're surprised how well it works. So could an entrepreneur maybe would you recommend they start with something like Python and TensorFlow, deep learning, and then just to get something working? Yes, I granted it won't be as efficient as it can be. And then maybe after they make a couple million, then they could step back and go, okay, we're going to hire some machine language experts to really pick. I mean, is that far fetched, or is that anywhere
No,
close to reality?
I don't think it's far fetched. I mean, I think, yeah, absolutely. I would recommend probably using Python. And, I would recommend, if you're going to go the deep learning route, deep learning is very much a data engineering problem as much as it is data science. So because you're talking about data sets that are much bigger, in general, deep learning only works when you have massive, massive data sets.
Okay.
And that means, and like I said, there's also that parallel processing component. So those data pipelines, learning how to build, work with distributed computing, whether it's Hadoop or Spark or, TensorFlow, it's good to learn the data engineering stuff if you plan to go into deep learning. And Python's good with that. The classic language for distributed computing currently is Scala, because that's the native language for Spark. So I actually had to learn Scala when I first joined ConsenSys. I was using R and a little bit of Java and Python, but I had to learn Scala, and I'm really glad that I did. because yeah, you can build some really great data pipelines. I think if you want to, speed things up a little bit, you can use one of these services like, not to plug, I don't have any connection to them, but Databricks,
Uh-huh.
for example, or some of these other things that help help with some of the data engineering stuff, so that you can be working with a cluster of 50 machines that are all kind of seamlessly working together, and then you really have the infrastructure to do deep learning.
Right.
um, yeah, but it does cost money.
All right. All right. So why don't we switch gears? So in the last part of our talk today, why don't we? And thank you very much for that introduction to machine learning. I think you opened our eyes. Now, again, I didn't expect you to make us all experts, able to get hired at Google tomorrow. But
Right.
okay. So with that basic understanding of machine learning, now why don't we discuss how it can be used in the blockchain space? So why don't we start by talking about your great work at ConsenSys in that area?
Sure. Sure. Yeah. So I think one thing, I'll just start with a kind of qualitative thing that I've used to think about cryptography and its relationship to machine learning,
Uh-huh.
because in a lot of ways you have some similar mathematics in both of those fields, but in one case you're talking about uncovering knowledge and learning things that you didn't know before, and the other is kind of about obscuring knowledge, making it impossible to break a certain
Right.
encryption algorithm or hash algorithm. So in a way, in a kind of interesting and almost like poetic way, they're sort of like these two different ends of the computer science wizardry.
Mm-hmm.
It's kind of like cryptography is about hiding information, and machine learning is the opposite. But
Right.
that said, they do combine in really interesting ways. So, to flesh that out a little bit more practically, because the blockchain is anonymous, you don't know who all of the accounts are. You can see all of the public addresses,
Mm-hmm.
but you just don't know what identity they're attached to, and you don't necessarily know much else about them.
Mm-hmm.
Um, so, sometimes you do have some knowledge of who is who, but basically, and another. So just to kind of follow on that contrast there, another interesting thing people like to say about the blockchain is that it's transparent. Um, and
Right.
some of the people that I talk to hear that it's transparent, and then they hear, well, it's also anonymous. So how can you really reconcile those two things? Because they seem to be opposite in some ways.
Right. Some things are
Transparency is
transparent.
about
Yeah. Some things are transparent. Some things aren't on the blockchain.
right.
Yeah.
Exactly. I would say the raw data is transparent, the public addresses and things like that. But the
Mm-hmm.
meaning and the actual knowledge of what that account really is or means is not transparent. So this is where machine learning can come in, because you can start to uncover the meaning behind different accounts, and what they what type of account it is, whether it's a fraud, for example, whether they might be involved in a DOS attack,
Mm-hmm.
um, a denial of service attack. Uh, so basically, I'll go back to how I got involved with machine learning at ConsenSys. So I initially got hired to work at a spoke called Alethio,
Mm-hmm.
and they're essentially blockchain analytics. So what they are doing is they're trying to add, give transparency to the blockchain on a bit higher of a level. And you know, let's see, I'm trying to think of the best way to sort of tell this story. Um, so it's easy to start off with unsupervised learning in that case, because you don't need any labels in order to look at all of the accounts on the blockchain and say, this one is abnormal because maybe it has an abnormally high transaction volume or
Right.
some other things. So you can do unsupervised learning and get some interesting knowledge that way. But things don't really get more interesting until you start thinking about labels. And this is where my work sort of started branching off and eventually became its own spoke. Basically, if we want to build something like a fraud model that
Hmm.
could try to predict whether someone is a fraud, or specifically, let's say, whether they're a Ponzi scheme, a very specific type of fraud,
Hmm.
in order to do that, we're going to need labels for some accounts that we know are frauds or
Hmm.
Ponzi schemes, and also some labels for accounts that we know are not Ponzi schemes. And then we can use that limited set of data to build a model that we can then apply to every account on the blockchain and try to make a guess as to whether they're a fraud.
So you're saying, if I understand you correctly, you're saying this is the idea of finding training data for supervised learning. So you're saying identify accounts with that we know are Ponzi schemes or doing whatever we're searching for, and then their pattern of activity. Then we could memorize that and then feed that into our machine learning algorithms. Is that what you're saying?
exactly, right, right.
Okay.
And right, the idea there is that this could actually start to give transparency to the blockchain on a knowledge level, not just a data level,
Hmm.
but actually being able to know, even if you don't know their identity, but being able to know something about a given account, like whether it's a fraud,
Hmm.
um, just by sort of looking at the output of this algorithm, which could
Right.
be very useful to people. So my first model that I built with machine learning was a Ponzi model.
Hmm.
So this was a really fun project for me. We went through a few different possibilities of what the most interesting model would be to build, and some of them would be simpler to build than the Ponzi model, but there was a lot of interest in fraud detection because there is, let's be honest, a lot of fraud in the blockchain. Um,
Yes, yes, that's what
yeah,
I was gonna ask you about. Okay, like for example, a lot of people are concerned about money laundering and funding of terrorist activities. So, in order to figure out the way that those people behave, like you said, you have to first catch some people to be able to then go back and analyze their history on the blockchain. But how those people aren't just going to tell you that they're doing those activities. So how are some of them?
well,
How are you going to find those people for your data points?
that's a very good question. So actually, it may be surprising that in a lot of cases with Ponzi schemes specifically, they actually will tell you. Uh, and this is something that is, one of those aspects of the blockchain where it's just the greatest social experiment of all time, because um, you actually do have a large number of people who have a Ponzi contract that they've made, and they'll post it on bitcointalk.org or on some forum, and they'll very clearly say, this is a Ponzi scheme.
Okay.
Get in early and make money, or get in late and lose your money. And essentially, think about this as a highly risky, high risk, high return
Right.
financial instrument. But they're totally transparent about their intentions. So is it really fraud? If that's the case, I don't
Yeah,
know.
okay, that's a good one because they're public facing. They're open about what they're doing. But what about things where people aren't open, not public about it, like money laundering? How are you ever going to find those people to analyze their behavior? Have you?
Yeah, yeah. So I think part of it's a bootstrapping problem. I think if we can take the data that we do have,
Hmm.
and Ponzi schemes, I think, are a pretty good proxy for other kinds of fraud, or at least
Okay.
that would be the assumption. So we
Okay.
can use that as a sort of core ground truth of, if we
I
have
see.
150 accounts here, and we can now identify the signature of the kinds of cash flows that a Ponzi scheme would have. Maybe as soon as they receive money, they immediately pay it out to someone else. That
Hmm.
could be characteristic, and there are ways that you could codify that as a feature. Or you just look at the patterns of when people send them money, who actually gets a payout
Okay.
in return for that, and how does that depend on when they got, when they sent the money. So the whole
Hmm.
get in early
Right.
concept you can sort of codify as a feature,
Hmm.
and you know then maybe those same concepts could apply to more general fraudulent contracts that maybe aren't transparent. Um,
Hmm.
and
Okay.
so
Makes sense.
Yep.
Yeah, no, I can see how this is perfect for your skills and your interests, analyzing the blockchain. Because as you were saying when we were introducing machine learning, deep learners and other learners want massive amounts of data, and preferably they would want that data without uh, uh, conflicting with privacy concerns and having to battle the American Civil Liberties Union to get the data and use it. And so the blockchain is exactly what you want, right? It's this massive amount of data that's out there, and it's already been anonymized, and it's intended for people to analyze. So yeah, I could see why that would be perfect for the type of work that you do. So yeah, it totally makes sense.
Right, right. And so the question of where to get this data from, though, is a really important question because, there isn't a central repository of this knowledge that's been curated by humans. There may be a lot more frauds out there where some people happen to have inside information, know that it's a fraud, but it's not in some central database of frauds. There is no central database of
Right,
frauds.
right,
Yeah.
right,
For
right.
that matter, really any kind of tag or any kind of metadata, in the most general case that's associated with accounts, there's no central place where all that metadata exists and you can search for it and maybe pay for it and download it, whether you're a data scientist or a hedge fund manager. So the FBI has some data. There's some interesting data on the Ethereum naming service about
Mhm.
identities. There's lists of exchanges, mining pools. They're all on different websites, but all this metadata hasn't been integrated into a single platform where you can search for it. And so
Mhm.
that's really what the spoke that I just started and was just approved yesterday, actually. Um, so
Oh, I see what you're saying. So yes, the raw blockchain data is available, but nobody has curated it into, okay, these are all the Ponzi schemes. This is all the money laundering, and that's what you guys have to do as an initial step. Okay, yeah, that makes sense.
right, right. It's an initial step, definitely for supervised machine learning, and that kind of was the initial use case. But then I realized it's not just for machine learning. It's kind of like what we're talking about here is just a lack of knowledge, of a knowledge database where maybe you're not a data scientist, but maybe you just want to ask a question like, you know, what is the total flow of ether through exchanges right now? And
Mhm.
in order to answer that question, you need both the raw data and the metadata because you can see all of the cash flows on the whole blockchain because all the raw data is transparent. But how do you know what the exchanges are? If
Yeah,
you know
which addresses the exchanges are using, right?
exactly, yep.
Right, right. Yeah, that makes sense. Okay,
That's the
so
metadata. Mhm.
yes, so certainly analyzing the blockchain data, there's lots of use cases for that, definitely, and you've opened our eyes to that. Now, let me try a different take. So, what about a person that is trying to apply machine learning to solve a problem, uh, some arbitrary problem? Can they necessarily use blockchain technology to help them? They're not. They might not be interested in analyzing the blockchain, but I'm trying to take it from a different angle. See what I'm saying?
Ah,
Can they use blockchains as well? Is there a reason that that would be suitable and helpful for machine language startups?
yeah, I think, let's see. If you're not applying the machine learning to the blockchain directly, so there are certain benefits that I could think of, that it may be a little bit of a stretch, but you have certain tokens like Golem or Ethereum is obviously the giant decentralized global computer, and one thing that is nice about that is I suppose that you could do parallel processing pretty well on that
Mm-hmm.
kind of a system.
Mm-hmm.
Yeah, I mean, I think to be honest, this is where the blockchain itself is kind of a separate concept from
Right.
machine learning.
Right.
Um, I would say they complement each other. So the blockchain itself isn't going to help you build a machine learning algorithm that's going to be faster than running on a supercomputer, most likely.
Right, and right. It's not going to directly help you with the machine learning portion of it, but it might help you in some unrelated way. So I was trying to I was trying to answer this question before the show, and here's what I came up with. So I was thinking, so what's the value add? One of the value adds of blockchains, and it's that the data is immutable. Right, it's trustless. You can't tamper with it. So, and what does machine learning do? It's generating, in a lot of cases, it's generating important data that people care about. So perhaps I could imagine an application where a machine learning application generates important information and writes it to a blockchain, and then that increases people's confidence that the data hasn't been tampered with.
Yeah, absolutely. I think that's a great example. So in the case of Facebook, for example, people's data is constantly being bought and sold on ad tech markets, and all of that data is being used as the input to various machine learning algorithms without necessarily knowing that your data is being used for that, so I think when it comes to controlling the flow of data that could be used as the input to machine learning models, it could be extremely useful because you have a much more granular, you could track the provenance of that data. And for example, there are also regulations involved with machine learning. When I was working at OnDeck building those credit models, you're not allowed to use certain features in your machine learning model that could be based on race or ethnicity or gender, and there are certain rules that you have to comply to when you're building your models. And so currently, the way that you enforce that is you have auditors come in and you check to make sure that none of the variables you're using in your model would be, socially unjust. But if you were able to use a blockchain to assess, whether or not a certain variable is highly correlated with one of those taboo categories, you could sort of enforce those rules automatically, and the inherent auditability of the blockchain might be able to save a lot of overhead from the auditors coming in.
Right. Yeah. So it's basically something where we need to enforce certain properties on the information, or make sure that it hasn't been modified, something like that. Maybe that's how we could help a machine learning application. Is that one of the things you said?
Yeah, okay. Absolutely. I think, there's also, this is where I would say the way that cryptography helps machine learning is as a balancing force rather than as a reinforcing thing. So, it's really the pitfalls of machine learning that I think cryptography and blockchain can help with, rather than, it's not going to improve the best case scenario, but it might help us hedge against, algorithms that are, that have side effects on society, or algorithms that may have potentially harmful consequences in the real world, especially, let's say, Internet of Things. The fact that we could have drones that are, using machine learning to determine how they are going to operate together, or even on the battlefield, autonomous cars, these things, these machine learning algorithms need to follow certain rules, I think, to ensure that they're actually beneficial to society. Okay. And maybe the blockchain can be used to enforce some of those rules. I know, for example, Tesla is looking at using blockchain to sort of immutably record all of the decisions that the automated driving system is making, so that it's auditable, because there's a lot of liability there. Right. So they need to be able to prove for sure that this is why the algorithm made this decision at this time with 100% certainty.
Right. Well, no, that's perfect. You just gave a real world example. So Tesla is generating this data, and there's reasons that they have to secure it. So that they might be doing a lot of machine learning regarding this data. But the point is that they have this need to secure it. So they use a blockchain for, like you said, for auditing and other purposes. So that's a great example. That's exactly what I was looking for. So maybe that's how they will, another way that they will be useful together.
Yeah. I think they're sort of the yin and yang is the way I like to think about it. Cryptography and machine learning. And I think, yeah, so it's probably scenarios like that where you're trying to balance the sort of the power of machine learning with the security of cryptography and blockchain in particular. Definitely.
Yes, very well put. Very well put. I like that, the last thing you said. Great. So yeah, I think you gave us a great introduction to machine learning. You gave us a great introduction to your work analyzing the data on the blockchain, and also we talked about how it could be used even with other machine learning applications that aren't analyzing blockchain data. Is there anything else that you want to mention that we haven't covered during our time?
Let's see. Well, I think I can say thank you again for giving me the chance to talk about all this stuff, and just mention my company Raker that's going to be working on gathering all this metadata and trying to leverage that. And also wanted to give a quick shout out to Vermont. I'm actually originally from Vermont, and their state legislature recently passed the first real blockchain legislation in the country. And I think it's really great that they're trying to be forward looking about that. It's all trying to get out in front of this fintech wave, bring entrepreneurs back to Vermont. And but whatever their reasons are, I just wanted to applaud the Vermont Senate and House of Representatives for passing this bill about using blockchain for public records and personal identity trusts, and this new concept called a blockchain-based LLC, which will be officially a legal type of entity. So, and also, just thought it might be interesting for your listeners to hear that this legislation is going on.
Right. So Vermont is one of the most blockchain-friendly states, you're saying?
Yes, I think that's probably correct. At this point, they have the most advanced legislation. There are some other states that are trying to pass similar bills. Actually, I have another company that I've been doing, that I'm the CTO of, that I've been working on for a few months. And that's a supply chain tracking company for legal cannabis products, especially CBD currently right now, and medical cannabis, and the general cannabis industry, whatever that looks like, the legal cannabis industry in a few years. And we're working on that in Vermont. And I think it's going to be a great application because, as you know, supply chain is a pretty good use case of the blockchain, I think. They're both state machines. And so, especially in industries that are kind of in the gray market and really in need of regulation and best practices, so that the good people can sort of differentiate themselves.
Do you want to give out the name of that company that you're involved with?
Yeah, sorry. The company's name is Trace. Okay. And my co-founder and the CEO is Josh Decatur. Okay. And so, yeah, we're going to be continue to work with the legislators there, and we've been talking with a lot of people. We have a bunch of letters of intent, and we're trying to work on a couple contracts right now with test facilities and extractors and growers, and so that's really exciting because I think it's a great example of how we can use the blockchain.
Right. Good. All right. Well, thank you, Paul, for chatting with me today and helping our audience understand machine learning. And I wish you luck with your continued work at ConsenSys. Best wishes.
Thank you so much, Chris. I really appreciate it. It's been a pleasure.
All right. Bye-bye.
Okay. Bye.